This is an example of a mechanism, and you don't need to know really all of the chemistry in order to draw a mechanism at this point. You need to be able to see where the bonds are being made and where they are being broken. So when we move from here, this is our reactant, and this is actually a 1, 2, 3, 4. This is a 4-heptanone. When we move from our reactant to the next intermediate, we need to see what gets broken, what gets made. So we're going to break this pi bond. So I'm going to draw a curved arrow with the electrons, the pi electrons dropping up onto that oxygen. That gets us to this point. But we also have this nitrogen. Now, with this nitrogen on this ammonia, we have a bond being made. I'm going to use green for a bond being made. So I'm going to go like this. We're going to come up to that electrophilic carbonyl, and we're going to make a new bond there. So one bond is being made, one bond is being broken. And that gets us to this first intermediate. So now we need to look between our first intermediate and next intermediate. So if this is our reactant and this is I1 and this is I2, let's just make it a little bit easier on us. I4, and then this will be our product. We can see between I1 and I2, we have this hydrogen that is attached. So we're going to have to make a new bond between oxygen and hydrogen. Now, I don't see anything else in my reaction mixture, so I'm going to come after that one because I drew it that way on purpose. And that bond is actually going to be broken. So the electrons from that bond need to point directly to that nitrogen because that's where they land, and they make a lone pair. So now between I2 and I3, let's evaluate that. We have this bond being made. So this is actually a bond right here, this new bond. So we're going to need a green arrow between our oxygen and pointing directly at this acidic hydrogen to grab that. And that's the only difference I have. I don't have a bond being broken there, just a bond being made. So between I3 and I4, what I notice is this bond is going to be broken, this bond here, because it's not in I4. So in order to break that bond, I need to take the electrons from that bond and point them directly at the oxygen. That makes water. It's a good leaving group. So then we're left with I4. So you can see how this cascade occurs. Now, between I4 and the product, I need to remove one of these hydrogen atoms. Let's just make a little red line there. One of these hydrogen atoms, and then I need to make a pi bond. So with red, I'm going to take the electrons from that bond and I'm going to drop it onto the nitrogen. And then those electrons are going to go from nitrogen down to the pi bond. Now, realistically, you could have gone, let's see if I change my color to something different. How about purple? You could have gone from this bond to this bond, but I'm trying to emphasize the point, the breaking and the making. And that would give us our imine product. So it's about seeing what bonds are being made and what bonds are being broken. We will get to the chemistry, the nitty-gritty, soon enough.